And today we will discuss about the Pass-1 of the algorithm. Okay, assembler Pass-1 algorithm. So we know that we are we have three types of assemblers: pass one, single pass assembler, two pass assembler, and multi pass assembler. So there are three types of algorithm I already discussed in previous class. In that we are concentrating only on two pass assembler. Okay, so here I will revise the two pass assembler. So what do you mean by two pass assembler? The assembler that converts the assembly language to machine level language in two passes. Okay, make two passes while converting from assembly language to machine level language. In pass one, what it will do, assembler scans the source program to find the address of each label in the defined program. Okay, so here it will scans the source program to find the address of each label. Okay, so wherever label is found, so that address it will take, and also it assigns the address of each instruction. Okay, two things, it will assigns the address in pass one. In pass two, what it will do, scan the program and obtain the machine code for each instruction, and finally it will generate the object code. So in pass one, it will get the address of label and instruction. Okay, so pass one it will get the address of label and instruction. In pass two, it will convert machine code for each instruction. Okay, so those are the two things, two passes. Okay, so in pass one, getting the address of label and instructions. Okay, so this is the two pass assembler. Okay, so in that we are concentrating on first pass, how the labels are getting address, and how mnemonic, how each instruction is assigned address. So all those things we are discussing in pass one. And also another important is, I already discussed the data structure used in design of assembler. Why I am telling once again, because these things we are using in algorithm. Okay, so if you know these things, then only you will algorithm. I already explained in detail operation code, table, location counter, and symbol table. So what is the use of operation code table? So this operation code table, so that is used to store the opcode, okay, instruction and equivalent mnemonic. Okay, so that is machine equivalent, that is instruction. Suppose add a, add b, add c, so whatever it may be, so add, that is the instruction. So that one you will call it as a mnemonic, and equivalent machine code. So it may be, it is in hexadecimal 0 c or a 1c, whatever it may be. So equivalent machine instruction we have, I already discussed in previous class. And length of the instruction, whether that is 3 or 4. Okay, so that is the operation code. Location counter, it will initialize with the starting address. Okay, and it will address of each instruction. Okay, so here the location counter, I already told that it will use the location and address of instruction. And okay, so it will address of each instruction, it will location counter will having address of each instruction. And symbol table, it contains the address of each label. That's all. Location counter, address of each instruction, and symbol table, address of label. Okay, so in location counter, in addition to address of each instructions, we will have a starting address, that is also there in location counter. Okay, operation code table, instruction equivalent mnemonic, location counter, address of each instruction, and also starting address, and symbol table, address of labels, each labels whatever we have used in instruction. So these are the three things: operation code, that is instruction, and equivalent machine code, that one we will call it as a opcode. Then location counter, that is instruction and their address. Okay, and third one is symbol table, label and their address. Okay, so these are the in smaller thing I am telling these things. Okay, so these are the three data structures we are used in this assembler. Okay, so here, so now we will come to pass one algorithm, exact algorithm. So you have written on assembly level language. So how that one will be converted to machine level in using pass one and pass two. In pass one, what we are doing in pass one, just we are assigning address to each label instruction. Okay, that's all. So we are not converting any to machine code. So here we will get the address of each one. Okay, so here anyhow you will start you will begin from the start. No, when you are writing assembly line, you begin from the start. Okay, so this is very, very important. Please concentrate on this. Begin. So program is begin. Read the first input line from the assembly level language program. So I have read. Okay, so if the opcode is equal to start. Okay, if the opcode is start. Okay, so if the opcode is start, then what you need to do? If it is that is start is nothing but a beginning of the program. So we need to save the address of that. Okay, if it is start, so where I need to store that address in location counter. Okay, so that one will begin. If opcode is equal to start, then begin save that save as operand. Okay, as starting address. Okay, save as a starting address. That start start is there in the opcode. Okay, so save that one starting address and initialize location counter to starting address. Okay, so location counter contains what? It contains the address of each instruction. Okay, so initialize that location counter with starting address. Okay, initialize the location counter with starting address, then write that line to intermediate file. Okay, so done. Start is done. What I have done, I have saved that one as an operand, and that starting address is copied to location counter, and I will convert that one to intermediate code. Intermediate, write that line to intermediate line, and done. That start is done. Then read the next input line. Okay, so it will end start. It will begin and end. So it's if starts, that is that start thing is over. Okay, done. What you do, if the opcode is start, then what you need to do, I need to save that one as a starting address and initialize that location counter to starting address. Okay, and write that line to intermediate. Okay, end. That's all. Then read the next input line. Done. Okay, so suppose if that is not a starting, the starting line is, in assembly language, that is not a start, then what you need to do, we need to initialize location counter with 0. That's all. Okay, if it is start, then save that address, save that starting address, and store that one to location counter. If it is not start, then initialize location counter with 0. That's all. Okay, so that is the first thing, starting. Okay, if it is start, save the address. Okay, save that starting address and initialize that initialize that starting address to location counter. Okay, so then write that one to intermediate file. So then after that, read the next input line. If it is not start, then initialize location counter to 0. That's all. Okay, done. Next, what I need to do, I need to process the next. I have read next line, and I first, second line, third line, fourth line, till I need to write to those those lines to intermediate file till where, till end. While opcode is not equal to end, you do these things. Okay, so while the opcode is not end, till that you need to process these steps. Begin if this is not a comment line. Okay, so if it is comment line agidre, no need to convert that one to intermediate file. If this is not a comment line, then if there is a symbol in the label, okay, so that is not a comment line. Done. Okay, so then if there is a symbol in the label, okay, label field, in that label field, if we have a symbol, okay, if there is a symbol in the label field, so okay, in what you are doing, so in assembly level, you need to check for the labels also. For label also, you need to get the address. So where you need to store the address, in symbol table. Okay, so here if there is a symbol in the label field, okay, so if it is there some symbol in the label field, then search for symbol table for label. Okay, so here search for symbol table for label. Okay, so if already exist, if found that label in the symbol table, set, and it means already whatever, so you will a number of times that label will be, that loop will be, so jump to that loop. If jump less than 10, jump to that particular loop. So first time, if it is not there, we will initialize to symbol table. So second time, it is processing. So at that time, every time we can't save that label address. Okay, so only one time we need to save the label address. If already found in the symbol table, the label is already found in the symbol table, set error flag. That's all. If symbol, if label is found in the symbol table, set error flag. Else what you need to do? You need to save that address to symbol table. Okay, so the sorry, you need to save that address to symbol table. Okay, so if a label is found in the symbol table, set error flag. Else insert label comma location counter, that is address, into symbol table. Okay, label and their address should be stored to sim tab. End symbol. Okay, got the thing. If label is found in the symbol, in symbol table, set error flag. Else you need to save that address, label and address to symbol table. Okay, that is the second thing. Okay, so first thing is what we did, that is start. Second one is label. Okay, so third one is opcode, op tab. Okay, that is opcode. We need to find, that is instruction. Okay, so for each instruction we need to get the address. How we will get the address? Here, search op tab for opcode. Okay, so in op tab contains what? It contains instructions and equivalent opcode. Op tab contains instruction and equivalent opcode. Okay, search for opcode. If found, okay, so if found, suppose you are writing add, so for that you will have a opcode 1C or a 2C, whatever it may be, and add R sub. So those are all nothing but an instruction. So the equivalent opcode is also available in the op tab. Okay, if found, opcode is found, so then add 3, that is instruction length. We need to get the instruction length. Okay, add 3 to location counter. If that is any instruction found, add 3 to location counter. So like that we will do for all instructions. Okay, for each instruction we will have a format 3. Okay, that's why we are adding 3 to location counter. Okay, so then after that we are okay, so for that we will have an instruction for all instructions. We will have a 3 bytes. Okay, so then we will declare variables, reserve word, reserve byte, okay, word, so constant, all those things we are declaring now. So for that, what is the length, and that length should be saved to location counter. Okay, if instruction found, add 3 to location counter. Else if opcode is equal to word. Okay, else if opcode is equal to word. Okay, so word agidre is how much? It will be 3 bytes. Okay, so then it will be, if it is opcode is equal to word, then add 3 to location counter. Okay, add 3 to location counter if opcode is equal to word. So word length is 3 bytes, 24 bits. Okay, in SIC machine. So that one we are copy to location counter. Else if opcode is equal to reserve word. Okay, so you are values you are declaring using reserve word. So at that time, then add 3 into operand. So suppose if I declared at 10 or 20 or 100, so 100 into 3, that length will be copied to location counter. Add 3 into that operand value, depends on that reserve word, what values you have defined, declared for that particular variable. That value in multiply with 3, that one will be stored to location counter. Okay, else if opcode is equal to reserve byte. Okay, so reserved byte, so then add that operand to location counter, because the reserve byte length is 1 only, 1 byte. Okay, so reserve byte or a byte, it will be, the length will be 1, word is 3. So for byte, if opcode is equal to reserve byte, okay, so if opcode is equal to reserve byte, then whatever the value, so suppose if I declared reserve byte is 10, a reserve byte 10, if I declare 10, then that 10 will be added to location counter. The length is 10 is added to location counter. Else, okay, so else if opcode is equal to byte. Okay, so if opcode is equal to byte, so then we are we are declaring a particular thing as a byte. Okay, so then for a character, that is nothing but a constant. Okay, so here what you need to do, we need to find the length of that constant. Suppose I have declared a b c d, so okay, x byte within quote a b c d I have declared, then the total length is 4 byte. So we need to find that length. So for that, what you need to begin, find the length of a constant in bytes. Okay, so if I declared a b c d, then length is 4 bytes, then that 4 will be added to the length, that add length to that location counter. That length of 4 bytes is added to location counter. End if byte. Else, it means if it is not instruction, if it is not reserved byte, it is not word, it is not reserved word, all those, if it is not there, then there is a set error flag, that is invalid operation code. Okay, and the next end, it is we are ending the, it is not a comment line. So we have done all those things. After that, write line to intermediate file. So like that, you need to check if it is instruction, add 3 to location counter and write that one to intermediate file. If it is word, add 3 to, okay, so location counter and write to intermediate file, like that. Okay, so like that, if it is opcode reserved, add 3 into operand value to location counter. Like that, you need to write all those things. Okay, so write line to intermediate file and read next input line. So after that, you need to read like next input line. Like that, you will begin till the end. You should convert all those things to intermediate file. Okay, so read the next input line. Okay, end. So we are ending the while loop. Okay, so then last one, write last line to intermediate file. Okay, so write last line to intermediate file and save, that is location counter. So what is the total length minus starting address? Total length, that is the last instruction address minus starting address as a program length. Suppose I got a total length 1000, starting address is 50, so then total length is 950. Okay, so as the program length and end in the pass. Okay, so this is the pass-1 of assembler. So I will tell from the beginning. Okay, so here, so first what we need to do, we need to start from the beginning. Okay, so that is, we need to start from the beginning. We need to read the first line. If the first line, that is if opcode is equal to start, okay, so if the opcode is equal to start, then what you need to do, you need to save that address. Okay, save that starting address and initialize the location counter to that starting address. Okay, so initialize location counter to starting address. Okay, so write the, okay, so save the operand as starting address and initialize that address to location counter and read the next line and write that one to intermediate file and read the next input line. You can, that is end of start. Else, initialize the location counter to 0. If it is not a start, initialize the location counter to 0. Okay, so then search for label. Second one is, so starting, then after that search for label. Okay, so till, that is while opcode is not equal to end, you need to do, if it is not an intermediate line. Okay, if it is not an intermediate, comment line. Okay, so then you need to search the label for symbol table. Okay, if it is found, if label is found in search sim tab, then raise a error flag, set error flag. That is, it means the duplicate symbol already it is available sim tab if label is found in sim tab. Else, insert that label and address, that is address is available in location counter to symbol table. Symbol table contains only label and address. Okay, that is end of symbol label. Okay, so then we will get an instruction for, if we get an instruction, add 3 to location counter. Okay, for each instructions, length 3 is added to location counter. Else, if it is a that opcode is a word. Okay, so if it is opcode is a word, we are declaring the variables as constant. Okay, so if opcode is a word, then add 3 to location counter. If it is reserved word, add 3 into value of operand to location counter. If it is reserved byte, add operand value to location counter. If it is byte, if it is a constant, then find the length of the constant and add to location counter. If it is not, it is not instruction, it is not word, it is not reserved word, then we will set a error flag. Else, and we will end the comment. I know that if it is not a comment line, so that one we are putting in, and read the next intermediate line. Sorry, write line to that intermediate file and read next input file. Okay, and we are ending the while loop, and write the last line to intermediate file, and you need to find the total length of the program. So that is the location counter minus starting address. Suppose a location counter of total length is 1000. Okay, so that is the last address is 1000 minus starting address is 50 or 150. So then total length is nothing but a 950 bytes. Okay, so this is the end of the Pass-1. Okay, so this is an algorithm. If they ask in exam, you should write this whole algorithm. For 10 to 15 marks they will ask. Okay, so what are all the observations? I will explain this once again. I know observations what we have made, that is the steps what we have done. Okay, so stepwise I will explain. The first thing is what it will do. The algorithm scans the first statement with start assembler directive. Okay, so first what it will do, if you know these steps, you can easily write that algorithm. Nothing is there. Okay, so if the algorithm scans the first statement, the algorithm scans the first statement with start assembler directive and saves the address given in the operand field as the starting address of the program. Okay, save. If it is first statement is start assembler directive, then saves that address given in the operand field as the starting address of the program. Then that whatever you have saved that starting address, that one will be initialized to location counter. Okay, so then write the first line to intermediate line. Okay, intermediate file. First line done. If no operand specified for start, which we don't have no operand for specified for start, then initialize location counter to 0. That one we have done. This is for start symbol, start assembler directive. So then next one, regarding label. If label is encountered, insert the label into symbol table along with the current location value given in location counter. Okay, what if label is encountered, insert that label to symbol table along with the current location, that is address whatever given in the location counter. If already symbol exists in the symbol table, set error flag. If a new symbol is found, save that address to location counter. Okay, save that address in sim tab symbol table along with current location value given by the location counter. Okay, that means label and address is saved in symbol table. If already present in the symbol table so then set an error flag. That's all. Okay, so then we have done. Then search for the mnemonic code in op tab. Okay, search for mnemonic. So that is instruction code. That is instruction. Okay, so that instruction is nothing but a mnemonic. So that equivalent is nothing but an opcode. Okay, so that one you need to search. If mnemonic is present, mnemonic, that is instruction is present in op tab. Okay, so then the length of the instruction is added to location counter. That is add 3 to location counter to make point to the next instruction. Okay, add location counter 3. Okay, so then okay, we have added 3. If it comes in op tab, in that we will have a opcode, that is instruction is there, we will add it 3 to location counter. Done. Okay, if it is not instruction, if it is a If opcode in assembler directory is word, okay, if opcode is word, then what we need to do, we need to add 3 to the word length is 3 bytes, so that's why we need to add 3 to location counter. If the opcode in assembler directory is word, then add 3 to location counter, because word takes 3 bytes in SIC and SIC XC machine. That's why we are adding 3 to length of that instruction, we added to location counter. If mnemonic is reserved byte, what you need to do, we need to multiply the operand value with 3 into operand value. Suppose operand value is 100 into 3, that is 300 is added to location counter, the result is added to location counter. Okay, if the mnemonic is assembler directory is byte, so byte length is 1. Okay, so then that length of the constant bytes will be added to location counter. If the mnemonic is reserve byte, okay, so if the mnemonic is reserve byte, then add the operand value. So that is operand value, if it is 2 or a 3, 4 or 5, whatever it may be, or how much value that operand value is added to location counter. Okay, if mnemonic is reserve byte, add the operand value to location counter. Okay, so we have done reserve byte, word, reserve byte, byte, and reserve byte. Done. Okay, process each line and write each line to the intermediate line. Okay, till that way, what till where you need to do, till end of the till end assembly directives comes. If the mnemonic assembler directives end, then the end of the program is encountered. Okay, when it comes to end assembler directive, it means it is a end of the program is entered. If you get that end of the program, then you need to find the length of the program. How you will find the length of the program? Current location counter, that is current location, it is assigning 1000 value, minus starting address is 50, that is 1000 minus 50, it will be a 950. So 950 is the total length of the program. Okay, so these observation we have made in assembler directive. Okay, so first what we need to do, we need to start from the beginning. Okay, so read the first line. If the first line is start, then what we need to do, we need to save the starting address and initialize that starting address to location counter. Done. If it is not start, initialize the location counter to 0. Okay, that is done for starting. If second one is label, okay, so if the next instruction is label, okay, so search for the label in the symbol tab. If it is found, set error flag. If it is not found, label and address is available in location counter. That label name and value of location counter is saved to symbol table. That is done for symbol. Next, what I need to do, I need to take the values of, okay, so I need to take the next instruction. So if the next is instruction, that is if it is opcode, okay, the instruction is next is instructions, then the instruction length is 3 is added to location counter. Okay, so if it is a word, okay, add 3 to, if it is word assembler directive, add 3 to location counter. If it is reserve byte, 3 into operand value, that length will be copied to location counter. If it is reserve byte, that operand value, whatever based on the operand value, that length will be assigned to location counter. If it is byte, then the total length of constant will be added to location counter. So those 4 things. Other than these things, there is an error, set error. So then end. Okay, so till when it end comes, it means this is the ending of the line. Okay, ending of the program. So then find the length of the total length of the program. So that is location counter minus starting address will be the total length of the program. Okay, so this is the Pass-1 assembler algorithm. Okay,